Hello, water managers and SWIMS users. I'm Errett with the Water Management Systems Division of the Hydrologic Engineering Center, and I'm covering HEC-ResSim within SWIMS. This is the fourth part of a multi-part video series to cover this presentation, so if you want to see the previous parts, check them out on the playlist. We've covered the introduction of HEC-ResSim, what HEC-ResSim is, what it can do, and why we would incorporate it within SWIMS. We've also covered integrating a HEC-ResSim model within SWIMS. So we've gone through the importing and linking of a HEC-ResSim model. And then we've also covered HEC-ResSim for real-time decision making so far. We've covered the data considerations, the standardized reports you would look at when looking at it. And so in this part, we're going to start going through the operation support interface and doing release decision overrides. So release overrides. This is kind of a big difference between planning and SWIMS and operations, real-time operations. Planning studies, release overrides is like a foreign concept. That's kind of a big no-no to change your simulation release overrides. You typically have to set up your algorithms of your rules, your physical constraints within the model itself for those studies. However, in SWIMS, for real-time operations, release overrides is probably the one thing that we encourage everyone to do. We want everyone to do release overrides because a computer shouldn't decide what releases are. They're humans that are involved, and this is how humans get to interact with the modeling. So this is one of the most powerful pieces of tools within SWIMS, is how the human brain becomes a part of the model. So I always like to think that the models don't give you the answer, the human makes that decision. And so this is how we get the human involved in the algorithm of SWIMS itself. So traditionally, within SWIMS, there's a release override editor. So this might be an option if you don't have the operation support interface set up. You go to release overrides, and it'll pull up the release override editor. And so you would go to either elevation target or release, select your reservoir, and then whichever outlet, or if you want to do the whole pool, you can do your release overrides in here. And there's fill options within here as well. This is probably an older method. This might still be being applied in real-time situations, but we really strongly encourage everyone to set up an operation support interface, the OSI. And so that's what this will look like. So when you open the OSI, this is where you can do release overrides, but it also gives you plots and gives you a lot more capability to look at the changes you're making, look at the conditions and how they change downstream, what it does to your reservoir, and you can do the computation from this interface. So everything can be interacted within this one interface versus the traditional release override editor. You'd have to make those changes or edits in there, save it, go outside of it, run the model, and then go back and look at the results. Where you can do this as a one-stop shop. This is a really powerful tool. So this is configurable by user, so you can set this up to however you want it set up. It's intended for developing overrides. There's tabs in here for organizing your variables you're going to look at. The variables you can look at, you can do reservoir overrides, whether they're pool elevation or outflow overrides. And you can also look at computed results. So maybe there's uneditable results you just want to see in there. For example, a downstream junction. You want to see what that flow is based upon your different changes you're making at the reservoir. So when you open up the OSI, it'll come up as a blank screen. The first thing you're going to do is you're going to add a tab. So you go to the edit menu and you go to add a tab, and you're going to give that tab a name. This can vary. You can also rename these tabs. Obviously, when you see the rename, you can also reorder these tabs. So if you make a tab out of order, you can reorder them and get them in the order you want to. So I'll show you different configurations on why you would name tabs certain ways. Once you have a tab, it'll come up as a blank plot, and there won't be anything down below, just similar to what's in the background here. The next thing will be to add a variable. So this variable could be the outflow, it could be a pool elevation, it could be a junction. Again, you can change these names, and you can also reorder these variables, and they're going to display in columns down here, almost like an Excel spreadsheet, if you will. So setting up a variable, once you have the variable, it's going to pop up this dialog. You're going to see the name of the variable that you've defined, and then there's going to be menu options here. So generally, more often than not, you're going to set up a reservoir element. You're going to select the reservoir, and then just determine what kind of variable you're defining. So reservoir release editor would be one thing if you're going to do a release override. If you want to do an elevation target override, you would select elevation. If you wanted to display like junctions, or you want to see something from the reservoir like a pool elevation, a computed parameter would be one of those that you'd want to put in there as well. And then also there's some other things down here. These are like the thresholds that you would show on a plot, like if you had a maximum target you didn't want to go above or some minimum target, you can add those in there for your release decisions. And then which viewport you're going to put it into. And this will make more sense as I show you different plot types you can make. You can also add other time series for reference, like guide curve, top of flood control, your inflow, other things you want to display with this variable. And when you click on the variable in the column, the plot pulls up, and that's where this time series comes from. So an example of that, as you can see, we click on Coyote outflow, there's the outflow that's up here. There's nothing else other than just one variable. So if you wanted to do release overrides for this, you would select through here and you can either type in down below here. There's also a graphical editor. I don't recommend anyone using this because I always like to know exactly what release, but you could also just draw in the release if you're trying to do something quickly, quick and dirty, real fast. There's fill options. So if you right click on this, you can go to a linear fill. So if you wanted to like highlight a certain amount and linear fill, there's a repeat fill. So if you wanted to highlight, say, this section of it and repeat the same release for however long, you can do a repeat fill. There's also this one, which is, I find it very powerful, is a repeat to end. I want to do the same release from this point all the way to the end of simulation. So that would the repeat to end. And then there's also the add constant. I want to add a certain value to it. I want to multiply them. These fill options are available. The other thing to keep in mind, you have the compute option here over to the right. Once you get your overrides set, you can compute the ResSim model from here. These options are really powerful. You can clear out any, some, or all of them of all of your release overrides. So what the clear all is it will clear out all your overrides, and ResSim will rerun and go back to basically what this green line is. It's going to go back through its algorithm, so you kind of reset it. So the OSI is really powerful on doing that. So some examples of how you can configure these OSIs. Here's one with one tab. We have multiple reservoirs here. So there's Lake Shelbyville, there's Carlisle Lake, and then there's a lock and dam down here. So there's 3 different projects within this watershed that are all displayed in one tab. There's only one editable variable in here, which is the outflow. So for example, we are selecting Carlisle outflow, and this is the plot that's been configured for it. But you can also create these variables and put them in here, and these are for reference. You can see the tabular information for the pool elevation, the tabular information for the inflow, for reference. And then also when you're in here doing your release overrides, there's our plot. So the way I have it set up here is there's a zone within this reservoir here, and then this is the guide curve, this is the look back period, and this is the simulation. Here is the release. This is the variable where you're going to edit. So the red is the observed, green is simulated. So if we wanted to edit reservoir releases, we could edit those and recompute. The other thing that's in reference in this plot is the inflow, which is black. And then this is a downstream control point. So we have the blue solid line is the flow at that downstream control point. And then this blue hatch pattern here is the cumulative local flow. Again, I like to display those in these plots when I'm trying to do my release decisions so I can understand what's going on. This is the look back time, so you can see how much flow has been going on downstream that's uncontrolled versus what's being coming out as a regulated flow. So these are very powerful during flood operations. So this is one way you can set up an OSI. Another way of doing it is you have multiple tabs. So this is another example. There's multiple tabs here for different areas within that watershed or multiple different projects. So this is the Ohio River, so there's a lot of block and dam projects. So they're broken down by different district boundaries. So this would be like all of the Louisville block and dams. And so there's different overrides. There could be overrides for pool elevation. For example, here they're doing an override for elevation to see what the outflow is required to meet that pool elevation. Or they can do outflow overrides and see what that's going to have an influence on the pool elevation. So there's different ways of configuring these. It's a very powerful tool to set up however you need to. So you can. I don't know if there's a limit on how many tabs you can have. I don't even know if there's a limit on how many variables you can add. But obviously, the extent of what you can view is probably what you would want to add for the variables. If you get beyond what you can view here, you might want to consider adding a tab. So some of the limitations we have within ResSim and just any of the overrides that we're talking about. Gate operations. So ResSim wants flow, which may not necessarily correlate to the way you operate projects. You might operate based upon gate settings. You will have to figure out how to convert those back to a flow to put them into your operation support interface or your release overrides. Flow is what ResSim wants. So you might need just to have a simple reference sheet or calculator to figure out what the gate setting might be for a different flow. So you might say, okay, I want my gate setting to be 1 foot. That correlates to this flow. That flow is going to get entered into the operation support interface to do my release overrides. So that might be a manual process you might do outside of it. You might have to also create some scripts to help you do those calculations. But that's a limitation. Hopefully that will be added in the future versions of ResSim for gate operations. The other thing I think is very powerful is the time step control. So ResSim by default is going to run at each time step. It's going to evaluate when it needs to make release changes. So if you run on an hourly time step, it's going to change its release every single hour. And that's probably not realistic to what you would do in a real world. So the way to change that or curtail that if you wanted to is to go into your reservoir editor. And so your operations tab, you have your zone and rules is what's going to pop up by default. Over here on the right, there's a decision schedule. So it's going to, you can change this to be, by default, this drop down is going to be each time step. You can change it to a regular interval. So every day, I only want this to change once a day. So daily, it could be 1 hour, 6 hourly. It's multiple different time steps in there. And I want it to happen, this is in UTC for Central Time, so this is 1500 or it's equivalent to 9 o'clock in the morning. This is when I want my gate changes to be, or my release decisions to be changed. So 1 time a day, I want all of those to be lumped in there. So you'll see more of a plot that's changing 1 time a day. Maybe that you want to do this only 3 times a day, every 6 hours if you want to. So that's one way of doing that. There's also, you can change these to be sub daily, like I said, but you can also change it, I think it's once a week, and I think once a month might also be an option in here as well. So things to think about when you're looking at this. You can also do a weekly schedule. So maybe it changes throughout the week. So in this example here, maybe on the weekends, they're only available for a certain amount of time. So you only can make your 3 decisions in a very truncated amount of time. So on the weekends, there's this time available, and then during the week, this might be the times available, and then maybe on Friday, we need to get that decision made earlier because maybe they end their day earlier. So you can make it a weekly schedule as well with different times in there. So this is very powerful. Again, these can be changed. I obviously probably don't want to limit your gate operations if you're in a surcharge event. So if you have these defined, think about this when you're operating your ResSim model. If you get into a surcharge event, those are probably happening on an hourly or even a sub-hourly instance where you're trying to keep up with the rate of rise or the inflow and pool elevations. So you might want to turn these off if you're in one of those scenarios and try to change it back to each time step. So things to think about when you're setting these up. So very powerful, but also be cognizant of the settings that you have for those. So in summary, we've covered ResSim and integrated reservoir model within the cavity. We've talked about ResSim alternatives and its look-back settings, establishing that model linking with HMS and observed data, configuring your extract groups. And then we've gone through using ResSim for real-time decision, the reports that are available, the plots that are available, how to do your release overrides, and then kind of the difference between like why this varies from a study planning model versus a real-time model. So we've covered a lot of ground with ResSim. If you need any more training within ResSim, again, there's an entire week-long training for ResSim that's very powerful if you're going to be the one to manage these ResSim models. So I highly recommend taking that course if you're needing more information on ResSim. If you have any questions about our software, need help, or are looking for additional training, check out these links. Also check out the description down below. Thank you for your time.